So, guys, today we're going to be talking about the periodic table and how it's organized. We touched a little bit on it when we were looking at the makeup of an atom, and we started discussing how to read the individual things from a periodic table. But now we're going to see overall how it is organized. These are things that are really going to help you really for the rest of the year. So I would definitely take my time in this section. I would possibly watch it more, review my notes, because this will definitely be something that makes a difference for you. So the periodic table is composed of increasing atomic number. And remember, when we talked about what atomic number means, it's the number of protons. So we start at the top left, we go to the top right, and then we just move down rows. Okay, they are always increasing as we go. So the way we first have it is by horizontal rows, which are called periods. I often tell the kids that rows equal rings. Okay, so notice this first row, this first period only holds two elements, this one and this one. And if you think about it, the first ring of electrons can only hold two. Okay, the second row has 8 elements on it, and the second row can hold 8 electrons. The third row has 8, and the third row can only hold 8. Okay, so that's why we taught you those numbers 2, 8, 8. They align with the first 3 periods. Once we get into the realm of 4, 5, 6, and 7, things get a little bit hinky. So we're just going to worry about these first 3 and a little bit right here for the 4th row. But we will not be touching this middle section this year. Beyond rows, which tell us how many rings they have and kind of how they act, we then go into groups, and those are the columns. Where this is important is that the columns share similar characteristics because what they have is the same number of valence electrons. That's going to be a very important term for you to know. And valence electrons are just the electrons on the outermost ring. So if I'm here and here, then I'm going to have 2 electrons on my outermost ring. If I'm here at 17, I'm going to have 7 electrons on my outermost ring. In the way we try to teach it to you and for you to remember it is you go from left to right, ignoring the middle, and for 13 to 17, you just ignore the 1 in the tens place, and that's how many valence electrons there are. So 13 becomes 3, 14 becomes 4, and so on. 18 becomes 8. The only one this doesn't work for, obviously, is helium over here, which is just a little bit weird. It's over here because it's what we call a noble gas. So, how do we organize it besides those things? Most elements are going to be metals. Okay, so everything in this light blue is a metal. Then you have metalloids, which have the properties of both things. And then you have nonmetals. Hydrogen's over here because it's the first. So it's a little bit weird. It's kind of like helium. They just needed a place for it. And it is number 1 because it has the 1 proton. So, but beyond that, everything else, metal, then metalloids, sharing both characteristics and nonmetals. So most elements are metals versus anything else. So how do we distinguish between them, or what were some of the characteristics of them? So metals are hard, shiny objects that are good conductors of heat and electricity. A conductor means it allows it to go through. Okay, so if we think about copper, copper is a great conductor of electricity. That's why we used it in our lab. That's why they use it in your house when it comes to the wiring inside of your house. It allows electricity to run really well. That's why we use metal for pans. Okay, non-metals are soft and brittle, and they are poor conductors of heat and electricity. So those are the things that you'll often find that are we're going to call insulators. They help stop the flow of electricity. And then you have metalloids, which will share the properties of metals and some properties of non-metals. How the groups are organized, you have 1 through 18, and then each group will have similar properties going down, again because they have those valence electrons that are in common. And how do we organize them? Well, the first group is called the alkali metals. Okay, they're soft and shiny, slash silvery and white with low melting points, and they are extremely reactive with water. Later on, I'll show you a video of sodium going into water. It's really interesting what can occur. So, when we say extremely reactive, we are not lying. Group 2 is going to be your alkaline earth metals. They are hard, shiny objects. They also are very reactive. When we talk about bonding and valence electrons, we will talk about what makes these so reactive, but it does have to do with the number of valence electrons that are here. That's part of why they are so reactive. Transition metals are the groups 3 through 12. They're strong metals that are ductile and malleable, so iron, silver, gold, all the things. We, for purposes of the periodic table, when we are learning, pretend they don't exist. They are tricky, and so for our purposes, when we do Bohr models and things like that, we just pretend they don't exist. You then have the boron family, being very original because boron is the first element at the top. Carbon, again, first element at the top. Nitrogen, and then oxygen. So these are the just very generic, like, hey, this is the first element at the top. We're going to name it after that. Group 17 are halogens. They are extremely reactive, often with these guys and these guys. And they form salts. They have colored vapors and low melting points. And then our last group is group 18, and they are the noble gases. And we call that because they don't react. They are very chill. They are happy to be by themselves. You will often not see them ever in a compound because their natures, which is they have a full set of valence electrons. If you notice, helium has a full set. It has 2. Then you go down, and this one will have 10, and this one will have 18. So these are non-reactive because their valence electrons are full, so they don't need anything. They're non-flammable, they're odorless and colorless, which is kind of ironic when you talk about the fact that neon is used to make colored signs. But that's more the powder that they put in the sign versus the neon itself. 2 more groups are down here. They are the lanthanides and the actinides. These are also known as rare earth minerals. You will hear about them more and more and more as you get older because they are what we use for electronics. And currently China has a monopoly on them, and so that's where a lot of our trade stuff comes into play, is these are in short supply but very high demand. They're all metals, they're all solids, and they are all radioactive. So that's where you'll see plutonium and uranium down in here.